Atoms are not the tiniest particle that made up the matter. For example, in diamond, it is made of carbon, but inside the atom there's more particles. So let's take a look at it. So here is the structure of atom. We have nucleus and then the shell. Inside the nucleus, we have protons and neutrons, and then orbiting the nucleus, we have electrons. Each particle has different mass and charge. For proton, the mass is 1, the charge is positive 1. And in neutron, same with proton, the mass is 1, but the charge is neutral, or it has no charge. And an electron is very, very small, so we consider the mass equals 0 and the charge is negative. That's why in the neutral atom, the total charge is neutral, because we have same amount of proton and electron, same positive and negative charge. Let me show you how we can calculate the mass and also the charge. If an atom has 1 proton and 1 electron, the charge would be 0. The addition of neutron doesn't change the total charge, because neutron is neutral, or it has no charge. If I take out the electron, the charge is positive 1, because you only have a positive particle, which is proton, and there's nothing to neutralize the proton. Now, if I have a neutral atom of lithium, and then I remove 1 electron from this lithium atom, you can see now the charge becomes positive. So it is the same as hydrogen, and it also applies for all atoms. When you remove the electron from the neutral atom, it will always becomes positive. Now if I have fluorine atom and then I add 1 electron, total charge becomes negative 1. So adding electron makes it negative, removing electron makes it positive. You can take more than 1 electron. Also, you can add more than 1 electron. For example, I have beryllium here. If I take out 2 electrons from beryllium, the charge of this atom now becomes plus 2. So the formula to know the charge is charge equals proton minus electron, because electron is negative, that's why we subtract proton with electron. So let me show you how to calculate the charge for this beryllium ion. And yeah, for the charge atom, we call it as ion. It's no longer atom. Now in this beryllium we have 4 protons and then electrons only 2. These are the electrons. So it makes the charge equals to 2. And then the sign is very important here, because we want to know whether it's positive or negative. So it's positive 2, yeah? You have more positive than negative. Okay, now let's working on to the negative ion. If I add 2 electrons to these oxygen atoms, that will create a charge of negative 2, because now we have more negative particles than positive particles. Now maybe you wonder why, when we were calculating the charge, why electrons are located at different circles. We have the first circle over here and then second circle. Remember, it is called as the shell. So we have first shell and second shell, third, fourth, and so on. Each shell has different capacity because of their size are different. So as you can see here that the first shell is smaller than the second shell. So the second shell can occupy more electrons than the first shell. First shell can occupy 2 electrons as its maximum. And then second shell is 8 electrons. So after it is full, it will go to the next shell. But if it's empty, you cannot immediately fill in the second shell, but it has to go to the first shell first. Yeah, the lowest energy, which is the one closest to the nucleus, as there will be attraction between positive and negative. That's why electrons must be filled in the first shell. So if we have the attraction between protons and electrons, what is the function of neutron? So let me tell you the function of neutron. When we have positive particles inside the nucleus, not only positive, actually negative particles also have repulsion. That's why you can see here that the electrons are not close together, but there's distance between them. That is to minimize the repulsion between same charge. So here is the function of neutron. When we have positive charge at the center of atom, we have to give like a glue. Yeah, let's say neutron is like a glue that minimizes the repulsion between protons. Okay, I think now we're done with the charge. Now let's working on the mass number of atom. Because the atom is way based on the proton and neutron. As we have seen before, electron has almost 0 for the mass. So for this hydrogen atom, we have 1 proton, which makes the mass number equals 1. If I add neutron, the mass number equals to 2. And if I add another neutron, that becomes 3. And yes, we can have hydrogen with various masses, and that will determine its stability. 1 proton inside the hydrogen atom is stable. If I add 1 neutron, it doesn't make any difference. If I add 1 more neutron, it becomes unstable now because it carries too much mass, or it's too heavy. Actually, there is more reason that makes the instability, but I'm not going to discuss that in this session. So as you can see here that we still have hydrogen even though we change the number of neutron, which then will change the number of mass. Yeah, can be 3, 2, or just 1 for the mass. And this phenomena, or these atoms with various masses of various number of neutrons, is called as isotope. Isotopes are atoms from the same element but different mass, or atoms with the same number of proton but different number of neutron. And for the application, we can use these isotopes for nuclear energy, yeah, also to cure cancer and many more. Okay, the last thing I want to tell you here is for the arrangement of electrons that we have discussed just now. There is a simpler way to write the arrangement of electrons rather than drawing this diagram. So you don't have to draw the circles, you just have to write it like this. When it has 2 electrons in the first shell, you can write it 2 and then dot or comma or bracket, and then write how many electrons is in the next shell. So in this second shell I have 8 electrons, and then comma or dot or bracket again, I have another 8. So from here we can calculate the total number of electrons, or vice versa. From the total number of electrons you can arrange it in its shells.